Hello everybody and welcome to this video. In this video, I'll be sharing you how we can move from SQL to NoSQL using AWS DynamoDB, right? I'm gonna be taking a very popular example of LinkedIn user can have several posts can have several comments, posts can also have likes. Let's learn how we can move from a traditional SQL relational model to a NoSQL, right? So allow me to share my screen where I'll be demonstrating you through the process. I do have a very simple lab at the end where we are gonna populate the DynamoDB table with the data and learn to query that, right? So, but first, let's try to understand how we can traditionally achieve this in NoSQL and SQL as well. So what I want to show you, the first thing is a simple post here. So if you observe a user, again, this is me, a user can essentially create a post, right? You can write a post on LinkedIn. Each post will have several likes. Post will also have several comments, right? So now how do we model this in SQL and how can we do that in NoSQL? The very first goal before starting is we need to model or identify the entities here. So what I have done is, again, I am just demonstrating you with a very simple example here. User might have name, alias, and profile picture. Post will have a text, body, a date. Now I want to see for a given user, show me all the post he has done, right? So I'll be referencing the user ID in the post column. Similarly, for a comment, the user will comment. I want to see who's the user who made the comment, on which post the comment was made, right? I also want to see who are the people who liked on the post, right? So these are some of my access pattern. Let's move to a relational model, right? So here, traditionally, you will have a user table where you would store all the user information such as name, profile photo, etc., etc., etc. Then you have a post table, right, where you would reference the user ID, right? And then post will have a text, a body, a date, right? And observe, we are doing something pretty amazing here. We are using a design pattern called Precompute design pattern. Now the reason is, if you observe this on LinkedIn as well, and I'll try my best to show you this so you do get an idea, right? So when you do open LinkedIn, what you observe is, there are total number of likes and comments, right? So when I click on that, then I can seamlessly paginate across the result. You see, it's an infinite scroll. You can see automatically it's loading, right? So of course you don't want to at runtime see how many comments are there, right? So what we have done here is, as soon as a post is inserted or a post is created, we initialize the like counter and the comment counter to 0. Now anytime there's a new like or anytime there's a new comment, we will essentially, for example, let's take here. So for a comment, right, I'll be inserting the post ID, the comment ID, and the user ID. So now I can see who are the user who made those comments, right? Right, I could observe all of that, right? And if you observe, I'm storing the comment, text, and date in a separate collection. As soon as a comment is inserted, what I'll do is I'll increment the post counter by 1. So that way, if I need the stats for a particular post, in this case, if you observe this particular post, I was able to pretty much get that information pretty quickly. So it's a design pattern where you pre-compute, you will keep on incrementing the counter, right? And of course, if you want to fetch, that's just the way the LinkedIn works, right? You can click here and then grab all the user and the comments, etc., etc. So that is sort of the model, right? So I hope that makes sense. So this is traditional relational model where you would do joins and get the data, do insert, write stored procedure. But when you come to NoSQL, things are a bit different. You do write down your entity, you do write down your access pattern. For example, for a user, fetch all the information. For a post, show me who are the people who liked, who are the people who commented, what is the total number of like, what is the total number of comment. Show me all the comments made by the user, show me all the likes made on a post by a user, right? So let's do a modeling exercise. And then again, I use the word I have a lab. I do have a lab where we will see all this in action. So here I'm saying user1. So I'm creating a user entity and I'm basically entering the user information like, profile picture, username, etc. in an object. Then I have a post. User can create a post. So here I'm saying post1, user1. And observe carefully, I'm referencing the user in a column. This is my GSI1. So now I can say for a given user, fetch me all the posts, right? I can fetch that. This is my global secondary index, which allows you to query the data with a different primary key. Similarly, as soon as a post is inserted, I will insert something called post stat counter. The value should be initialized to 0. Now let's say a person liked. So I'll say like 1 user 2. This was liked by user 2. I'll reference, observe carefully, I'll reference the post and user. So for a given post, I can fetch all the user who liked on that, right? Hopefully that makes sense. What I'll also do is every time a like or a comment happens, I'll simply increment the counter. So for a given post, I can easily fetch the stats, which LinkedIn shows you, right? On a post, right? I could easily fetch that, right? Hopefully that makes sense. Similarly, the comments. So for a given comment, I can, if you observe comment 1, user 2, I reference the user and the post. So for a post, I can fetch all the comments, etc., etc., etc. So hopefully on a high level, that makes sense. Now, what I do want to show you is a NoSQL model, and then I'll show you this in DynamoDB in action, okay? And I'll leave all the resources for you guys. So what I'm gonna do, I'll try my best here. I think that's the one, visualize, aggregate. So this is how my data looks like. So for here, I can see for a given user, show me all the information. So the user like, comments, post, all the view about a user I can see on this GSI. My second GSI is basically stats for a given post. Give me all the stat, how many like, comment, reaction. For a given post, show me all the like and who are the user who made that like, right? I'm easily see how I'm querying my data using GSI. For a given post, show me all the comments, right? Just the way the LinkedIn did. We essentially broke the like and comments into a separate view. Now let's see a lab and understand this concepts in much better way. So over here, I made my infrastructure code. Here I'm creating dev.linkedin table. I'm defining my attributes, my PK, SK. Observe the names are pretty generic. User post GSI, this means I want to get everything about a user, right? Post user comment GSI, which means for a given post, fetch me all the comments by a user, fetch me all the likes by a user, and then I essentially create my 3 global secondary index, which you see on line 44, line 50, and line 56, okay? Now, what you will do is you will come here and say serverless deploy. This will create your table. Now, I wrote a small Python script which will generate fake users. Again, you can test for 1,000, 2,000, how much ever you want. So I'm saying how many users I want. I want 4 users, and I'm saying each user will have 2 posts, and each post will have a like and comment. You could tweak and play with this number. So the code, it basically first creates the user, right? And then again, it's the same format I'm doing it here. Observe it, okay? So here I'm saying user hash and the user ID and the user object, right? If you observe, right? So now I'm creating a user, then for each user, I'm generating a post, the text, the date, when the post was done. Then at the end, what I do is I get the user post, and then I create comments and I create a like. So basically this will populate my data. Let's hop over to DynamoDB and see this in action. So the first thing that I will do is after you run the script, this will populate the data. Click on explore table. And the first thing that we want to do is we want to scan the table just to show you how the data looks like. Again, same thing because we have been through the modeling exercise. So let's understand, for example, let's take a user, right? So now see how you're able to query this data. Click on query. So for this user, right, I can get what the name of the user is. So I can click here, which will show me all the attributes about a user, an address, birth date, email address, alias, username, right? Now let's say I'm interested to see what all interaction this user has done. So I'll go on the user post GSI view. So I'm saying show me all the interaction by this particular user. So I can see this user made a comment, this user also essentially liked, and then this user also made a new post. This is the post ID. So let's say I want to see on this post who are the user who liked. So I can click on the likes GSI, I can query, I can grab all particular likes, and I can also particularly grab all the comments. And here you can see, you can read the comment text, you can filter out the comment by date, right? And if you want to see who the user is, the name of the person who commented on this, you can now query my standard table, the first one, and give the user ID. And here you go, that is the information about the user. So this comment was essentially made by Alexander Dustin Lynch, that's the email address, right? So what I did show you is how we went from SQL to NoSQL, and we did model a complex scenario. This is the art of single table design. I encourage you guys to come to the project folder, and all the resources are there. So this is the infrastructure code, say serverless deploy, then this will generate the data for the table and learn how to query this data. And also the Excel spreadsheet is given here. So I hope you guys will go and try this labs out. Let's wait for a second for my camera to load. All right, so you did observe that we did model a complex scenario from SQL to NoSQL. DynamoDB is super popular, right? And you want to learn how to do data modeling. You want to learn how to query data. What is GSI, LSI? If you designed it correctly, you can get amazing performance, literally in milliseconds, right? That's the power of DynamoDB, you guys. I hope you guys enjoyed. I showed you a demo as well. All the resources are there in the description, so do check that out. And if you have questions, let me know. Thank you so much for watching. I'll see you guys in the next video.